Well, welcome to Tim Time Projects. Today I'm going to try and muddle through some type of a procedure or process to do this alignment on the HQ-120. That's the bird on the HQ-129-X. And look at this schematic. I think the first thing that I need to do is, from what I'm reading, is find out what the frequency of the crystal from the crystal filter is before I make any adjustments and just kind of leave that at what it is. And then I think we're going to center the alignment of the IF around that. Um, so here's kind of the schematic, and I'll zoom in here and I'll show you where I'm going to actually make the connections, both the input and the output, and we'll watch this, and then you can watch it on the scope. Now, I'm trying to develop this all, so this might be a long, arduous process and a boring video to watch. So watch what you want, or if there's anything that comes of value to you. And I know there's going to be a lot of things I'm going to have to redo again. This is just kind of a this is my rough draft of alignment because I'm really not even sure how to do this, and I'm no pro at this, so I'm learning as I go and watching what's worked for other people and seeing what's going to work for me. A couple of things I know that I have to deal with is one, I'll make a video when I test the all the voltages of all the pins from the vacuum tubes because they give you a nice chart for that, and I'll probably do that. Another thing is the alignment I'll do in this video. Just for the IF, it works pretty good, but I can still the some of the AM sounds a little bit muffled, almost like the alignment, almost like the IF filtration is too narrow. And you'll see a couple places where uh, I'm not really sure what they're telling me to look for when I look at the uh, at the scope. This isn't simply aligning it for peak. You actually have to kind of look at the filter through a scope and see what happens. So after I do this, I think I'm going to go back and redo it again. And I'm going to widen my sweep from just a few megahertz. I think I'm going to go with, or I mean kilohertz. I think I'm going to go with a 20 kilohertz sweep, and I'm going to widen the base, even though I'm going to lose a little bit of the gain. I think that'll help me. And then the last thing is the BFO. While it works, it doesn't work real well. You have to have the input gain turned way down to get it to work. So I would imagine that's indication that the BFO signal is a little a little too weak. So I'll look at that and we'll go from there. But have fun, and I'll throw in some of these schematics whenever I can to maybe help. I know there's not a whole lot of these radios out there that people are going to be doing, but at least you'll know where I'm at. Well, today on Tim Time Projects, we're going to try and find what the frequency of our crystal filter is in the HQ-129-X. And the first thing I did, I came with some instructions and I modified some things I found. And one of the best explanations for finding this, the simplest probably, was on Philco Radio, one of those old talk groups. And the fellow that made the request or the recommendation first, he says, is to pull this tube out. It's the 6K8 tube. And then, as you can see, well, I don't know if you can see, but this, where is it? This guy right here, this black test lead you see, is connected to pin 4 of vacuum tube 3. Let me see what, I just want to confirm what vacuum tube 3 is on this. Vacuum tube 3 is one of the 6 SS7s. There's like 3 or 4 of them in there, so but I have them marked underneath, and that's the best thing to do is mark your frame underneath where the tubes are. That way you don't have to keep trying to find them, especially when there's multiple tubes with the same number. But anyhow, so I have that. I'm feeding a signal in to pin 4 vacuum tube 3, and then I'm looking at the output on my scope of pin 8 of vacuum tube 4, which is kind of right above it a little bit over here. And we can look in the schematic to see where they actually connect to. But if you look, let's see if I can show you. You can see my scope. Here's the vacuum tube 4. It's way up on the top of the frame. So let's take a look-see now at the scope. And what I'm doing is I'm starting with a 455 kilohertz signal. I have everything set like for the normal alignment, so this is going to be a little bit crooked. But it was the best I could move this scope here in front of you. There we go. I think that gets the light out of it too. All right. That's 453 kilohertz. And as I go to 454, it gets smaller. So we know that's the wrong way. And right now I have, actually I'm going to put zero filter. Yeah, I'm not using any crystal filter. So that's at 454. 453 is about the same. Looks like I got a little bit smaller at 452. 451, it's getting worse. You can see that as I move further away from 455, the signal gets worse. So we'll come back up. Here's 453, 454, 455, and as I start going up the other way, you see 456, 457. So we know the crystal's pretty close to 455, or at least the IF is. So now I'm going to put this crystal in position 1. And as you can see, we're not at 454. Let me try 455. Nope, that got worse. There we go. So when I put the signal generator or the function generator to 453, now that it's going through the crystal filter, 453 seems to be better than anything. Let's see. Oh, 452, it goes away completely. So 453, and so 453 seems to be our guy. So I'm going to move it up to like position 4. This is going to make the crystal even tighter, the crystal filter. All right, and now I'm going to move away and move into hundreds of hertz. I mean hundreds of kilohertz point. So we're 453 point something, 0.0 right now. Oh, it's getting better. 453.1. 2 didn't seem to make much difference. And 0.3 gets smaller. So we'll leave it at 453.2. Now I'm going to go up to the maximum filter. This is the thinnest frequency response that I'd be going to. There's the 453.2. There's 0.1. That's definitely not right. 453.2 is good. And 453.3. So it's going to be, our crystal is 453.2 kilohertz. So it's pretty close to 455. I mean, it's really like about 450, 453. So it's 2 kilohertz off. That's an old rock that's in there. I don't know if you're going to clean it and get it any better than that. So anyhow, the idea is now that we want to set the IF to be that the same as the filter is. So that way when you turn the filter on 1 notch, you're just thinning down from the crystal frequency, not the regular 455. I know it sounds kind of confusing, but if I had it set at 455, it would be okay until I hit the first position of the crystal. I'll show you. Here's without the crystal filter in it at all. And there's 455. You're thinking, oh, that's a pretty good signal that's coming through. But as soon as you turn the first position on for the crystal filter, it's completely gone. So if you had the crystal filter set to 453, get that nice signal, it's turned off, you go to the first position, and it actually got a little bit better. Well, it stayed about the same, but when I first clicked it, it looked like it got better. Hey, the second position, still pretty good. Third position's getting a little smaller, and it will get smaller as it goes through the crystal filter, but anyhow, you can see that that's why you need to tune your IF to match your crystal, excuse me, your crystal. So now that we know we're going to aim for 453.2, and I'm just going to go for 453 probably, but I'll write that down. 453.2 kilohertz is our filter. That's what we want to set the IF to. So that's step one. Let me turn all this stuff off. All right, so the next step we're going to want to do is to set all the IFs, but you don't want to just set them for maximum. On this particular radio, and Mr. Carlson has an interesting philosophy for aligning these, but you don't just want to set it for peak, you actually want to set it for width, width, how wide your IF is too, because sometimes if you don't have it wide enough, the AM frequencies or the AM channels will sound all muffled. So that's what we'll have to take a look at next, is how to do that. All right, so the next big topic we're going to work on is trying to figure out how to get the placement of everything for the IF alignment using the scope. So here I'll zoom in as best I can. You can see there's 4 different spots where I'll be putting the input signal, and the output signal will stay fixed as best I can tell right here, where it says monitor, and then we'll start to move further away from the monitor as we continue to put in the signal, and then lastly we'll go to the top of the one vacuum tube, and I mentioned that I don't know if I should take the grid lead off or not, but it doesn't say anything, so I just leave the grid lead on. There's no strong signals in the area or anything like that. So we'll move on with that, and this might become even more boring, but that'll be it. All right, well, today we're going to be looking at the trying to align the IF with the scope, and I'll try and explain how I have everything hooked up, because there's just so many different ways you can do it. So what I actually have, and I believe I brought the schematic up at one time, but we can always do it again. I'm looking at, through the entire thing, I'm going to look at the output being measured at V6, which is a 6H6, and it's going to be pin 3. And then I'm going to move through all the stages. So right now I'm at the first stage. It's the input stage right before the third IF, and it's going to be at pin 4 of V5, which is one of the 6 SS7 tubes. And then I'll adjust T4 and T5, which are, I believe, they're called the input and output diodes, but that's just what they name the transformer, the location they're at. Now the scope, how do I have that hooked up? And let me see if I can get a signal going. First, I'll turn up the radio. And you can hear that tapping. That's the pulse that I'm using. Let me see if I can get a pulse to actually show on here. So channel 1, let's go to millivolts. All right, so I'm actually looking at 2 traces on the scope, and I'll zoom you into that. Well, before we'll actually look at some of the settings. And I'm not sure how important some of these settings will end up being, but if I turn, if I turn sweep off over here, oh, never mind, you can't see it. I have to show you on the sweep generator, and I can get you a picture of that as well. I'll actually just take a picture and bring it up, maybe if I get my phone to work. So on the sweep generator, I'm sweeping with, because this radio, the widest band it'll do is AM, I'm sweeping with a total of 10 kilohertz from 448 to 458 kilohertz, and that's because the IF frequency is 455, and I think you remember at one point when I checked my crystal was at 453 point something, so we're estimating at 453. And this isn't going to be that accurate that it's going to matter that much, but uh, anyhow, that's what I'm scanning is between there. I have the sweep time set at 90 milliseconds. And you'll see as I take that up and down, it's not really going to make that much difference. Here it goes. I'm going down. Well, I was going down. Put it back at 90. There's 80, 70, 60, 50. And you're going to get, it's going to be the same, but it's just you're going to see more of it on the screen. But it doesn't really change anything. So we'll put it there. That is right there at 60 milliseconds. That's my sweep time. My amplitude is 50 millivolts peak to peak. Right, I have a kitty cat here telling me stuff too. What did you want to say? You're not sure. Okay. All right. So back over to the radio. As you can see, there's two lines. The lower one, the pinkish looking line, that's actually that's what my sweep is getting triggered from. So I'm using the output from the sweep output from the scope. There's like an external trigger, not from the scope. There's an external trigger on the function generator, and that tells the scope when to trigger. So what I did was I plugged that right into channel B so I can see when it's going to trigger, and you can see that pretty much the on time for this, it would trigger every time right in this area, the way I have it set up. I smell some heat. I just want to make sure I'm not burning anything. So every time the pulse goes positive, it starts to trigger, and then it does its thing. So this area here, I'll point, this area here should be the on time that we're actually looking at. And in my in my world, what I want to do is follow their instructions, but I'm looking right about the middle of this should be, I'm sorry, it would be right about here. Right about the middle of that should be where I'm peaking. And it looks to me like I'm peaking past that. So now, keeping that in mind, I'm just using the triggering as a what do I want to say? I'm using it as a marker so I know where the middle of this wave was, because if I just use the external trigger and triggered it by the scope, I'd never see where it was. So I would have to keep checking my frequency. But by this, I can assume that the on time, the time it turns on, and then the time it turns off. Right in the middle of that would be my 453 kilohertz. So let's see if I can kind of align it now like they said, where I want to align these two for maximum amplitude, symmetry, and pattern coincidence. And I believe what they mean by that is that nothing crazy happens outside of the pattern. But I'm going to start with this one first, which is, I think that's T4 or L27 T4. And we'll just see what happens as I move this. Loosen up that little lock thing I put on there. I'm watching through the scope, so I'm actually going to zoom it in a little bit more so that I can see. And there's a cat. Kitty cat. No. Well, a cat break. Come on. Keep going. There you go. Get your butt out of the way. How am I supposed to concentrate with this going on? Anyhow. All I see is it's getting ever so slightly larger. But not that much. So let me try the other one. Which would be T5. I'm going to actually, well, you can't see what I'm doing, but I have to tilt the radio a little bit so I can get to it. So here I'm going to adjust T5 now. I see that's moving my pattern one way or another, if you can see that. And I'm imagining we want the peak of it to be right where the cat is. Kitty cat, can you move? Okay, well, you know we're going to have to cut this out of here because your big gigantic head's in the way. All right, this is what I'm going to try to accomplish. So what do they want me to do with this now? T3 L26 screws for maximum amplitude without disturbing the pattern. All right. And that would be these two guys here. So you can't see where I'm at here. I'll try to do this. So that's going to be these two right here. So I'll adjust those. I don't know if I can get both me and the scope in, because I'm actually using the picture of the scope to make these adjustments. So let's see. And I am using a metal tool, but we're on the outside of the can, and this is a piece of metal that sticks up here, so as you can see, when I get the screwdriver near it, makes no difference whatsoever. All right, so I'm going to try and maximize this. That's changing the pattern, but you can see it's actually, in my mind, making it a little bit better as far as a thinner pattern. But now it's not, it's starting to minimize it. And my screwdriver fell out. Geez, I'm really popular. I think that's kind of the happy medium. I'll try the next one. Same story with this one. That one seems to be about where it should have been. All right. Now we want to move to B3 pin 4, and we'll probably get even more amplification. Oh, where's my light at here? There's 3, there's 1, 2, 3, and that would be 4. Can't see that number. 1, 2, here's 4 down here. Now I'm not using anything in between my function generator output lead and the tube. I tried it with a capacitor just to minimize my presence, and when I do, it's just terrible. The signal doesn't work right, so nothing works right. So the manual doesn't say to use anything there. I was just trying to eliminate things. Okay, there we go. Wow, we got a big signal there now. So let me, and the meter won't, or the function generator won't go any lower. All right, that's kind of a funky looking thing. So what are we looking for here? T25, the lower plate inductor for maximum amplitude. Well, let me see which lower plate inductor. I think I know what they're talking about, but I want to look it up. The crystal filter. Let's see. Switch the input lead to grid 4 of the first IF tube V3 and adjust the lower plate inductor L25 of the crystal filter for maximum amplitude at the center of the curve. All right, so that would be, we'll take you back out. That's going to be this one right here. Because this is the crystal filter housing and this is the lower. So we want to go for maximum. That's not maximum. It's about maximum right there. And it actually moved us over, so you can see now we're at the peak there. Okay. Let's see, input. Let's see. So now the next thing it says is to input the signal to the mixer tube, which is the cap, the external cap on this tube right here. It doesn't say to not use the existing cap. It just plug this on along with it. I'm sure this signal would be stronger, it would wipe out anything, but I think we'll remove the... Well, it doesn't tell me to take it off, so I'm not going to. I'm going to plug it right onto that. So let me turn this back off again. And let me get this out of here. And I'll have to go on this side now. And it would be this tube that's right up here. Again, it doesn't say to use anything in the coupling, it just says attached to it. So that's going to be that that wire that I fixed. So hopefully I can get right on there. And I need a ground. All right. Hopefully I'm on that good enough. All right. Let's turn this on. Now where does it tell me next? The two screws adjust T124. So let's see what the... Oh my, that's gotten way bigger. Even still, let's go to shrink that down. And goodness, that's a horrible signal. All right, let's see. What does it want? It wants for tall selectivity curve with a slightly flattened peak. So maybe I can move that together. Let's see. I believe it's going to be these two here. But let me check. Just T1, L24, two screws. T1, let me find that. T1. First IF transformer, T1. So let me see. T1 got to be this guy that's done in here. Let me double check. Yeah, this, and I'll see if you can see where I'm pointing. So I get that out of my way. Okay, down inside here, below this, there's two screws in here, down inside, and those should be what my target is. Well, looks like about maximum amplitude. Let me see if I can adjust this one to get a slightly flattened peak. I think that's a close-up. I think it's as flat as it's going to get. So I'm trying to bring it so that it peaks a little bit higher. I think that's about the best I can get it. Now I wonder how unprecedented it would be to go back and align everything while leaving the input there, instead of trying each stage at a time. If I would get a more desirable output, or if that would mess everything up. Well, let me just see. Let me just see what happens when I start with this guy here. I'm going to make our signal, not that signal, that signal a little bit bigger. Reposition it there. Okay, it's getting smaller, so that definitely put it back where it was, right at that mark. Let me see. I got to tilt the radio to get this one. That's this guy right here. And that one came about a little bit, but pretty much stayed the same. Next are these two guys. It's shifting me, but it's staying the same. We'll leave it where it's at. So if I move that one, this should put me back on the other side. All right. That's those two, that one, then the last one would be these ones again. Let's see if I can move that over ever so slightly. Well, I think it's moved over then. That's good. So now we'll have to try it and hear how it sounds. So let me take all this stuff off. I still have a resistor hanging under here that I was using as a test point too, so I'm saying that out loud so I remember to unresistify it, or remove it rather. All right, I'm going to set this down, move this resistor up out of the way. Put the speaker up here. Move this stuff out of my way. Let me go get something to use as an antenna. Oh. Now it's the middle of the day. I don't know what we'll get here, but we got a keycat. The AM band. That's what I expect to get in the middle of the day.
Tune in to SEC Network for a full day of SEC football coverage, starting at 9 a.m. with Marty and McGee and SEC Nation.
You don't have to ride around through all this. I'm going to go and look. 5. Let's try 10. All right. About 15. And lastly, 20. Oh, actually, this may make a bit of a difference. Well, which way I go with this thing? Put on the 0 or what? Let's put on the 0. Let's pause this. Okay, well, I don't even know if this is worth releasing this video, but I'll release it anyhow. If you want to watch it, you unfortunately, unfortunately, you're at the end here, but I'm not sure what value it could be. But this was just pretty much a video of me poking around on with this radio. So maybe the next one will be more informative. Thanks for watching, and if you stuck through it, and hopefully it helped put you to sleep. Take care.